I'm going to give you a quick demonstration of this Tektronix oscilloscope. It's a 7603 mainframe with 3 plugins. There's a 7A26 Y amplifier here, 7A18N Y amplifier. Both of those are dual trace. The 18 is a slightly lower bandwidth and doesn't have readout facilities. And the timebase is a dual timebase, the 7B53N, which has 2 timebases, delayed and so on, but also doesn't have a readout. I'll just run through all the functions of the scope to show that it works, basically, and then check 1 or 2 calibration points so that you can see that it's in good shape. If I switch on now, we'll first test the first plug-in. I've got a scope probe set up here. Probe's not included, it's just something I'm using to test the equipment with. So we've got 100 millivolts per division. If I put that to ×10 probe in the calibrator there, you can see we've got 4 divisions, and I can increase that to 8 divisions. The adjustment's pretty good. I'll try the various different sensitivities. You can see it works through all the different attenuator settings as I go through there. Triggering is good. Same on the other channel. If we start, there we go, channel 2. Dum dum dum. All works, and the readout's in good shape. Let's change that. So it goes all the way up to 5 millivolts per division. It's all working fine. You can change the bandwidth on that one, give a slightly cleaner trace if you're looking at slower signals, which is sometimes quite a nice feature. There we go. We can also test the other plug-in, which I'm using a different probe for because it's got a slightly different input capacitance. So I should change the trigger to the right-hand plug-in. Again, oops, wrong one. All the different attenuator settings work okay. All fine. Check the other channel on there. So you've got a total of 4 channels which can be on screen at the same time. There we go. And so that's all 4 channels showing that they all work. Just for fun, we can put them all on at the same time. If I put it into alt mode on each of those, I can put it on chop, speed things up a bit. There's nothing triggering it at the moment. There we go. We've now got all 4 channels visible at the same time. Turn the intensity up so you can see what's going on. So that's 4 traces. Only one of them's actually got anything on it. We'll return to normality, and I'll show you the time base. If I go to 1 on there, that's just an ordinary square wave. I'll show it from the calibrator. I'll show you the time base. It works, goes through all of its ranges from very slow all the way through to much faster. We'll show the fastest time base speeds a bit later on. Nice feature of the dual time base is that it's possible to center that up a bit. Use to highlight a piece of the trace and then zoom in on it. So if I select the intensified mode and select a faster speed, you should be able to see. It might be a bit hard to make out on the camera. If I adjust the intensity, there's a piece of the trace which is highlighted there as I change the delay time. So if we highlight, for example, this edge here, just about make out that, and then I change to delayed sweep, we've now, let's turn the brightness up, you can now see that edge in detail, and I can roll along the waveform with the delay time to examine in detail what we're looking at. So that all works fine. We go back to the normal sweep. So that's the basic functions of the oscilloscope. All the various triggering modes and things are all there. Now I'll show you that the sort of mainframe calibration is, as far as I know, correct. None of this is traceable calibration, but it's sort of good enough for the work I've been doing with it. So I'll switch off before changing plugins. Let's pull out this one. This is a special calibration plugin which just provides a reference signal so we can see that the screen is correctly set. Put it on the left mode there. We should have There we go, it puts a grid on the screen. It might come out a bit funny on the camera. And I can adjust that to be centered, and each of those lines lines up with the graticule on the scope, showing that the mainframe is set up correctly. So it should work with any plugins that you put in. You can actually swap over the time base and the calibrator to do the same thing horizontally, but I won't bother with that now. It doesn't tell us anything else. That's it. Sort of meets the Tektronix spec as far as I'm aware. Last thing to do is to demonstrate the bandwidth of the scope, for which I will switch off again and put the standard plug-in back in. Once again, the calibration plug-in is not included. That's just something I use for servicing my own scopes. Also included this one. Okay, so we'll start with the bandwidth measurements. If I start with the left-hand plug-in, this should have a bandwidth of something over 100 megahertz. I have here a very fast pulse generator on the end of this wire with a very fast rise time, so I plug that in and we trigger correctly, and I have to speed the time base right up to see what's going on here, and we'll crank it all the way up to the max, so times 10 magnification, move the position all the way along, so that's now at 5 nanoseconds per centimetre. It's probably a bit hard to make out on the camera because it's fairly light in here, but that shows a rise time of about, oops, if I position it so you can see it, 3 to 3.5 nanoseconds, which is something over 100 megahertz bandwidth, which is in excess of what this mainframe is specified at, so that's definitely working well. The 7A18 plugin is a bit slower. Let's try that out. Oops. There we go. So that's there. That's triggering off the 7A18 plugin. You can see that one sort of 10% to 90%. It's about 4 nanoseconds rise time, which is about 90 megahertz, which is again exactly what you'd expect. I think it's rated at 75 in this mainframe, so again in typical Tektronix fashion it's performing better than the book says it should. I've been using this scope intermittently in my workshop for a few years, but I don't have room for it anymore, yeah, so I will pass it on. Two of these plugins are a bit unusual. They're the ones without readout, because they're just ones I happen to have lying around. Doesn't mean they can't do anything, it just means there's no readout on the screen. The left-hand plugin, on the other hand, does have, you can see it's 50 millivolts reading there. What else is unusual? Oh yes, this mainframe, it's got this spectrum analyzer graticule. You probably can't see it very well on the camera, but it does have a log scale down the side, so if you're into making logarithmic measurements, then it can do that. Yeah, so there we go. Tektronix 7603 with 7A26, 7A18N and 7B53N plugins. Thank you for watching.